You at campus?
No, I'm not on campus. I'm at my wife's office.
Oh, it looked like a classroom almost, I thought.
It's her office. So yes, actually she's also she's a student in Stony Brook University.
You're taking up her space then.
Yes, yes. I bought this space from her. At home, I have my daughter, Ronnie. So I don't want her to interrupt you. Okay, I just here. It's great. Let's see, got 15 students. Let's wait a couple of minutes and then start. Okay, so let's start. So as I said last week, the focus of these 3 weeks will be dynamic programming, which is extremely hard, in my opinion. So I'm not sure. So how's your so is there anyone who already finished the route cut? No? Okay, so is there anyone who have already started that? Oh, I see. I saw one yes in the chat area. Okay, you finished route cut. Great. It means that you have very good understanding of the pseudocode already. Okay, great. So from the programming side, I don't think it's very difficult for you to finish your homeworks on dynamic programming, but to understand it is really hard because, as I say, it involves a lot of math. And today we're going to continue this topic. So before I start the new topic, I want to go a little bit over a little bit what we have learned so far. So last week we talked about we mainly learned the route cut problem. So in the route cut problem, we're giving a price array like this, which tells us, okay, how much money can you make from selling a route of certain length, and then you're giving an integer n, which so okay, I also say one sentence, one message from the chat area saying that I have to reread chapter 15.1 like 3 times. Yes, it's totally worthwhile. So I'm going to explain why it is so worthwhile to have a very good understanding of dynamic programming when we are learning it rather than later. Okay, so great. I really like your efforts. I admire your efforts. I wish that I could work as hard as you when I was when I was in my college as an undergraduate student. So okay, the input is that we're giving the price array and also an integer n, which tells us okay how long is the route we get, and so we basically want to find the best way to cut the route so that we can maximize the total revenue. And so we learned a very simple solution, which is to enumerate all the possible ways to cut the route. But then we realized that we got the complexity of that will be 2 to the power of n, which is we gave a couple of names like exponential complexity or NP-hard or computationally infeasible. Let's just use exponential complexity so far, and we say that when n is as large, if we were giving a problem whose complexity is NP-hard or exponential, so it means that when the problem size is only as large as 100, and we need around 1,000. So we need around this. Okay, so in totally around $30 billion to finish the calculation, even with the best computer in this world. So and then we said that okay, so it's going to be impossible for us to enumerate all this solution, all the possible cuts. And so then we learned so next we learned a mathematical formula over here, which is really short and simple. So here we got Rn as the maximum revenue for a route of length n, and Pi is the price for a route of length I. So what this mathematical formula tells us is that when we are giving a route of length n, now we don't worry about, let's forget about all the possible cuts. Let's just first worry about the leftmost cut. Suppose that we make the leftmost cut at here, and in total the matrix is as long as n. So let's say we make the leftmost cut at I, meaning that we are going to leave this part, the left part, intact. We are not allowed to further cut it. Otherwise, we can cut the right part, the right route as many times as possible. So then we basically get the left route whose length is I, and the right route whose length is n minus I. So because we are not allowed to further cut the left part, we have to start directly, and the money that we can make from it is Pi. And for the right part, because we are allowed to further cut it, so the highest revenue that we can make from it is Rn minus I. N minus I denotes the length of this subroute. So in total, if we make the leftmost cut at here, then the best amount of money that we can make is Pi plus Rn minus I. And over here, we just need to try all the possible places, all the possible places of the leftmost cut, and find whichever gives us the highest revenue. And then we will take it as the highest revenue for a route of length n. Okay, do you still remember this equation?
Yes.
Okay, so this equation is really beautiful, right? So because it helps us. So with a very short equation, we basically can know how to calculate the highest revenue for a route of length n. But then we realize that even though this formula looks cool, it does not reduce the complexity. We still get exponential complexity. The main reason is that we have to repeatedly solve a certain problem many times. So for example, here we solve R1 4 times, we solve R2 2 times. So then this comes to to the application of dynamic programming. With dynamic programming, what we do is that every time when we solve a sub problem, we store its solution somewhere, so that we in the future, if we are asked for that solution again, we don't need to work on it. We just directly retrieve it from memory. So So basically, this is the philosophy of dynamic programming. We just store the solutions of the sub-problems. And then we learned the pseudocode. Over here, we say that with this, we will be able to reduce the complexity from exponential 2 to the power of n to n squared. So this is what we learned last week. And over here today, I want to emphasize one point is, okay, so no matter in your job interview or in your future job, so sometimes you will be say getting you will be situated in a place where you don't know if you need to apply dynamic programming or not. So here I'm just going to introduce at which circumstance you will need to use dynamic programming. Okay, so which is, okay, if you say that the problem exhibits the optimal substructure property, you should use dynamic programming. So this is just, so if you say this property for a problem, if you say this property, directly go for dynamic programming. Okay, so it's just a no-brain choice. Okay, so what is this property? The optimal substructure property basically indicates that, okay, the optimal solution to a big problem incorporates the optimal solution to its sub-problems. Okay, so this is the optimal substructure property. And so again, the optimal solution to a big problem incorporates the optimal solution to its sub-problems. So here we can say that this is the mathematical formula for the rod cap problem. What is Rn? On the left-hand side, what is Rn?
Like the length, all right?
No, n is the length. Here, I wrote it over here, okay? Rn is the maximum revenue for a rod of length n. Okay, so basically this is the optimal solution to a problem whose size is n. To a problem whose size is n. And then on the right-hand side, we have Pi as the price of a rod for a rod of length I. And then on the right-hand side, over here we have Rn minus I. So Rn minus I is basically the optimal solution for a problem of size whose size is n minus I. Okay, so here, because we know that ni is larger than 1, larger than or equal to 1 and smaller than n, so we definitely know that n is larger than n minus I, correct?
Yes.
Okay, so basically on the left-hand side, we have the optimal solution to a big problem. And over here, we have the optimal solution to our sub-problem. Okay, so basically here we can say that the optimal solution to a big problem incorporates the optimal solution to its sub-problem. And this is exactly what this is exactly the optimal substructure property. The optimal solution of a big problem incorporates the optimal solution to its sub-problems. And this is where you should apply dynamic programming. Okay, so in the future, as long as you see a mathematical equation where the left-hand side is the optimal solution to a big problem, and the right-hand side is the optimal solution to a sub-problem, you should directly go for dynamic programming. Okay, and actually in your job interviews, or you will definitely, in your coding interview, definitely you will be asked at least 1 or 2 questions related to dynamic programming. And your job interviewer is going to help you to reach this mathematical formula, a mathematical formula like that. And after you see a formula like this, just you have to say dynamic dynamic programming immediately, okay? Because this shows that you have the logic of computer science. Okay, so and then today let's learn a new problem, and this is called I think this problem is going to be more interpretable for you. It's going to be easier for you to understand. So so here we can see that the problem the name of the problem is longest common subsequence. So the input of this problem are two strings, and we want to find the output is just the longest common subsequence between two strings, between these two input strings. But what is a longest common subsequence? Let's use this as an example. Suppose that we have x and y as two input strings, and then we want to find their longest common subsequence. So the longest common subsequence between them is basically BCBA, because BCBA shows up in x. These characters do not have to show consecutively in x, but they just need to show in the same order. So B is the first, that following that is C, and another B is after the C, and another A after B, okay? Similarly, we have B, C, B, A in Y. So we can say that BCBA shows up in both X and Y. So BCBA is a common subsequence between X and Y. But is this the longest common subsequence? Can we find a common subsequence which is longer than this? Can you find a longer common subsequence between X and Y? No. Okay, I see one message in the chat area. No. Okay, yes, actually, this is the longest one. We cannot find anything that is longer. Okay, so from this example, you can see that the longest common subsequence is basically a sequence of characters that shows in both X and Y in the same order, but they don't have to appear consecutively in X and Y. As long as they show in the same order, the longest common subsequence is basically a common subsequence with the largest length. Okay. So this is the definition of the problem. Any question or any confusion with the definition? Yes or no?
No confusion.
No.
Okay. Okay, cool. So then I'm going to continue. Okay. So here is another example. Okay, because for this for this instance, because X and Y are relatively short, so we can also find the longest common subsequence between them by ourselves within 1 or 2 minutes. But here, okay, if we are giving a much longer input sequence, here, for example, we got S1 and S2 as here. So then, what is the longest common subsequence between them? So before we talk about the solution, okay? Do you know what does S1 and S2 stand for?
String 1 and string 2.
String 1, string 2. But what does these two strings stand for? What do these two strings stand for? It's the DNA. Okay, because our DNA are basically consists of characters of A, C, G, T. So these are the these are the DNA samples, 2 DNA samples. So a very famous application of longest common subsequence is to calculate how close are two people. Are they, if they are check if say if we got a baby, or we are not sure who is his father. So, and then we find a couple of a list of candidates. Then we just compare the DNA of this baby with the DNA of those candidates and find which one. We check the similarity between their DNAs by using longest common subsequence. So in general, your DNA sequence and the longest common subsequence between your DNA and your father's DNA should be very long. The longest common subsequence between your DNA and your father's DNA should be very long. So that is how we do that. Okay. So then this is the application, or very famous application of longest common subsequence. And over here you can see that this is the longest common subsequence between these two DNAs. Okay, so then next we just formally define this problem at this. Okay, suppose that we get two sequences, X and Y. Here we got X. So let's assume that X includes M's characters and Y includes N characters. And Y includes N characters, and then our objective is basically to find. So now we want to simplify the problem. We're not worrying about what is the longest common subsequence. Let's say for now we just worry about the length of the longest common subsequence. So we want the output to be an integer, which tells us the length of the longest common subsequence between these two input strings. Okay, so this is the definition of the problem. And so next I'm going to spend around let's say how long, 10 to 15 minutes on some mathematical things. Okay, so if you don't understand this, for the next 10 to 15 minutes, just these two slides. Okay, if you don't understand it, it is fine. It does not interfere with the your understanding of the pseudocode. But I would definitely encourage you to pay attention, because if you understand this, you will feel the beauty behind that. Okay, so it's really beautiful. I mean, I'm a guy who has been doing computer science for how many years? Since I was 18, so 14 years. And the longer I'm dealing with computer science, the more I love math, because computer science is just one extension of math. We basically use the computer scientists are basically using computer programs to solve mathematical problems. So that's why I said the more you are doing computer science, the more you love math. And okay, so some mathematicians formalize this theorem. So they prove this theorem. So what they say is that let X and Y be two sequences, and let Z be the longest common subsequence between them. If the last character, which is XM, the last characters of X, which is XM over here, and the last character of Y, which is YN, if they match, if they're the same, then we have ZK as XM, and ZK the same as XM and YN, and then ZK minus 1 is the longest common subsequence between XM minus 1 and YN minus 1. So this formula or this theorem really looks very hard for us to understand, but I'm trying to explain it for you, explain it to you in a better way. Okay, so the thing is, okay, suppose that we are giving X and Y with X1, X2, X3, and then we have X, say M minus 1, and XM, and we have Y, capital Y plus y1, a sequence of characters, y1, y2, y3, yn minus 1, and yn. Okay, so here, let's say we have this. Okay, so so x and y, and also so for every character we just use lowercase letter. So we have for single characters we denote it with lowercase letter. So we have lowercase x1, lowercase x2. But if we're talking about if we're using a capital X or capital Y and also a I, it means that we are so thinking about the first I characters of X. So X, it will be X1, X2, X3 until Xi. So capital X with a footnote, meaning that the first I characters of a sequence. Okay, make sense?
Yes.
Okay, so just keep that in mind. We'll use that later. Okay, so so what this mathematical equation tells us is this. Okay, so but before that, I want to I don't want to talk about the mathematical formula. I just want to talk about something which is more straightforward to you. Okay, suppose here we got a list of men. Okay, we use M1, M2, so M3, and then let's say say 99, M 100. So suppose here we got 100 men and 100 women, 100 women. Okay, so we want to pair we want to get let's do not think so okay, not 100 women. Let's say we got 90 women. Okay, so our objective is to get as many of them married as possible, as many pairs married as possible. So what we do is that, okay, first we will let the last man and the last woman date. Okay, we'll let them date. Okay, so if they are, so after a couple of days, if they say, okay, yes, we want to build a family together and get married, so then we say, okay, we will take them in the married couples, M100 and then W90. So we say, okay, we got one married couple, and then we will let the first 99 we will let the first 99 men and the first 89 women. So we try to mix. We try to get as many couples from them as possible, plus this one couple. So let's say if we got 80 couples, so married over here, and then so the total number of couples that are married is basically 80 plus 1. Correct? If we got 80 couples married over here, and then we got another couple here married, so in total we got 81 couples married. Correct?
Yes.
Okay, so similarly, okay, so when we are talking about the longest common subsequence, we do the similar thing. Okay, we first check if the last character of X and the last character of Y, if they match or not. Okay, so if case one is that if XM matches YN, or similarly, if the last man and the last woman decide to get married, so we will okay take that. Okay, what we do is that we will take the longest common subsequence between the first here. Notice here, this is the capital X. We'll get the longest common subsequence between the length of the longest common subsequence between the first m-1 characters of x and the first n-1 characters of y. Let's say, okay, what is the length of this? So basically we are going to do this. Okay, so this is the result. Okay, we're going to take them as a one matched character, and plus we're going to find the length of the longest common subsequence between the subsequence for the first m-1 characters of x and first n-1 characters of y, and take the length of that. Say suppose this is as we for example here we got 80. The length is 80. So in total, the length of the longest common subsequence between x and y would be 80 plus 1. The same as what we discussed over here. Does it make sense?
Yes.
Yes.
Yeah.
Okay. Okay. So this okay, cool. So this is an easy case because the last pair just matched. We're fortunate. A more difficult case is this. Okay. So for example, when we are matching the man and the woman. So what if we get a case, okay, where after they date a couple of times, they said, okay, we're not a match. They don't want to get married. So what we do is that, okay, we will say, okay, maybe it is the man's problem. Maybe it is this man's problem. This man just say this man is not a good option to get married with. So then what we do is that, okay, we will take the first, we'll eliminate this man. We say, okay, we will take out this man from the matching. We'll say, okay, we will let the first 99 men match with all the women. Okay, so this is what we get. So we are going to exclude this man over here. Okay, so we say, okay, since you guys do not want to get married, so the problem should come from either one of these two people. Okay, so for now, let's just say we try to eliminate the man first and from the matching and say, okay, and let these guys match or get married. Let's say we got maybe 70 couples built from this. Or then the other option is that, okay, we say, okay, maybe it's not that man's problem, it's this lady's problem. So we will eliminate this lady from the matching. So we got M1, M2, M100. So we will eliminate we only eliminate the lady from the matching. The last lady from the matching. So we got the 89 women over here, and then 100 men here. Okay, we'll try to get as many couples from them as possible. So here, let's say we got 75 couples married over here. Okay, so then so remember, okay, our objective is to get as many couples as possible. So then which solution are we going to go for?
75.
Yes, 75 one. We will take whichever is longer. We'll take the max between them. Okay? Okay, so this is how we get as many couples married as possible. And over here, okay, just in case that the last character do not match. Do not match. If this is not a match, we will either take out the last character from X, meaning that we will take the longest common subsequence, LCS. So do you know what that? Oh, so by the way, do you know what does this operator mean?
Is not absolute value.
Not absolute value. So if the input is a string, it returns the length of the string. It basically returns the length of the string. Okay, so here we are taking the longest common subsequence between these two strings, and then we take the length of it. Okay, make sense?
Yes.
Yes.
Okay, cool. So then what we do is this. Okay, we are going to try to say if it's not a match, then we'll try to eliminate the last character from X. Basically, we will take the longest common subsequence between the first m-1 characters of X matched with the first n characters of Y. Basically, which is all the characters of Y. It's like we eliminate this character and then get the longest common subsequence. So from the remaining characters. Okay. So let's say, for example, the length is this. Okay, we denote this as the length, and then, or the other option is that we keep this character. We keep the last character from X, but instead we eliminate the last character from Y. So then we take the length of the longest common subsequence between the first X characters from M characters from X, which means all the characters from X, and then n-1 characters from Y. Okay, so suppose if we eliminate the last character from Y and we got the longest common subsequence length as this. Okay, so we will take whichever is longer. The same as what we do over here. Okay, so we either eliminate the last man or the last woman, and then say whichever gives us more couples. And over here, what we do is that we either eliminate the last character of X or the last character of Y, and to say whichever gives us a longer common subsequence. Make sense?
Yes.
Okay. So basically, this is what this theorem tells us. Okay. So if it's a match, then we take the match character, and then take the plus the longest common subsequence between the first m-1 characters of X and n-1 characters of Y. Otherwise, if it's not a match, we take the max between by eliminating either the last character from X or the last character from Y. Okay, so this is what this mathematical what this theorem tells us, and then following that, people design this very beautiful formula for us to infer the longest common subsequence, the length of the longest common subsequence between two characters. So first, okay, here we got so Cij. What does Cij denote? Okay, suppose we have X. Here x1, x2, xi minus 1, xi, and m minus 1 and xm. And we got a y, y1, y2, yj minus 1, yj, yn minus 1, and a yn. Okay, so so suppose this. Okay, basically Cij denotes this. Okay, the longest common subsequence between the first I characters of X, the first I characters of X, and the first J characters of Y. So is this. We take the first characters I characters of X and first J characters of Y. We take the longest common subsequence between them, and the length of that would be Cij. Okay, make sense?
Yes.
Okay, so here, if we want to know the longest common subsequence between X, all characters of X, and all characters of Y, so it will be what? It is equivalent to what? It will be equivalent to what? Say what?
It's Cij.
No, not Cij. CMN, meaning that we use all the first m characters of x and all the n characters of y. If we include all the m characters of x and all the n characters of y, and we get a CMN, right? So that is going to be the length of the common the LCS between x and y.
So is Cij just the length of the longest common subsequence of x, y, right, and y?
Xi and yj. The first. So LCij is the length of the LCS between the first I characters of x over here and the first j characters of y. So one I is as large as m, but I is as large as m. It means that we're considering all the characters from x. And j is as large as n. It means that we're considering all the characters of y.
Yeah, I see. Thank you.
Okay. So, any question with this? With this?
No, pretty straightforward.
Okay, cool. So then, so what this mathematical formula tells us is that if I is 0 or j is 0, we have Cij as 0. What does that mean? What does the first case mean?
If they're empty,
Yes, if say we are including 0 character from, if I is 0, it means that we're including 0 character from x. It means that we got an empty string. Okay, we're basically taking the worrying about the longest common subsequence between between an empty string and yj. Yj can be j can be anything, can be any value from 0 to n. So if we're taking the longest common subsequence between an empty string and another string, what is the result? It has to be an empty string with nothing in it, right?
yes.
Okay, so then the length of that will be 0 automatically. Correct?
Yes.
Yes.
Okay, so makes sense, right? So this is pretty much like what we discussed last week. So R0 equal to 0. Right? You can make $0 from selling nothing. So this means that if any of the two substrings that we consider is empty, then the length of the longest common subsequence must be 0. Otherwise, okay, if say here we are worrying about the so if the last two characters of the two substrings that we worry about, if they match according to our previous discussion, if they match, then we will take we will use this one, the matching character, plus the longest common subsequence between the first m-1 characters of x and the first n-1 characters of y, and take the length of the LCS between them plus this one. Correct?
Yes.
Correct? Okay.
Yes.
Here, because we are worrying about the first I characters and first j characters. So basically, we only need to substitute m with I and n with j. So this becomes i-1, j-1. Okay. So here, LCS. Here, LCS xi-1 and yj-1. The length of the LCS is basically, according to our formula, it is basically C what? If we have this, then it is basically Ci. It is basically Ci minus 1, j minus 1, right? Right?
Yes.
Okay, so basically here we're just using Ci minus 1, j minus 1 plus 1. And then we just substitute this formula with the red color over here. This is what we get. Okay, if the last character from these two substrings match, so then the length of this LCS between them is like this. Cij is like Ci minus 1, j minus 1 plus 1. We're going to take the longest common subsequence between the first I minus 1 characters and j minus 1 characters. The length of that plus this matching character. Make sense?
Yeah,
Yes.
Yes. If you follow my previous explanation, it totally makes sense, right? It just follows this case. And otherwise, okay, if they do not match, previously what we did is that we either eliminate the last character from X or the last character from Y and take the LCS between the remaining characters and say whichever gives a longer LCS. Correct? So
Yes.
here we only need to substitute M with I and N with J. M with I and N with J. So then this becomes the max of Ci minus 1 J and Ci j minus 1. Correct?
Yes.
Okay. So that is how we got this. Okay. Cij is basically the max between Cij minus 1 and Ci minus 1j. Correct?
Yes.
Okay.
Yes.
Cool. Great. I'm so glad that some students are following me exactly. Okay. So it means that they understand it from the theorem here. So basically you can say that this mathematical formula is a translation of this this theorem. Okay. So so now we understand the three cases of this formula. And okay, so type in 1 if you understand it totally. Just type in 1, or type in 0 if you don't understand it. It doesn't matter. Okay, I just want to say how many of you can understand it. Okay, I see 4 ones, 5. Okay, quite a few. I'm so glad. Okay, guys, you're paying attention. I'm great. Okay, if you understand this formula, the inference of this formula, it is great. It is excellent. If you don't understand it, it doesn't hurt for you for the following discussion of the pseudocode. Okay, but I want you to know one thing. Okay, one thing that I want everybody to understand is this. Here, Cij is the optimal solution to a problem. Whose size is I by j. Okay, here when we talk about the size of the input, where we usually use n. We usually use n because previously when we talk about sorting the arrays, then n is the length of the array. And previously when we talk about the rod cut problem, then n is the length of the rod. So we only have a single number to denote the size of the problem because we only have one input. But here, when we're considering the LCS problem, the LCS problem has two inputs, x and y. So we have to use two numbers to denote the size of the input. So here, the size of the input is basically two numbers. Here on the left-hand side, the size of the input is I and j. Okay. On the right-hand side, we have the optimal solution to a problem whose size is I minus 1 j and j minus 1. Optimal solution to a problem whose size is I minus 1 j minus 1. And here we have the optimal solution to a problem whose size is I j minus 1 and whose input size is I minus 1 j. So here we can see that we got the optimal, on the left hand side, we got the optimal solution to a bigger problem whose size is I and j. And on the right hand side, we have the optimal solutions to this sub problem whose size is I minus 1 j minus 1 I j minus 1 I minus 1 j. So in other words, we see the optimal substructure property, the optimal solution to a big problem, incorporates the optimal solution to small problems. Okay, so and then this is where we should this is exactly the optimal substructure property. Substructure property, and which means that we should use dynamic programming. Okay. This is something that I want everybody to understand. Okay, so to identify the optimal substructure property from the mathematical formula, and then derive the instinct to use dynamic programming to solve such a problem. Okay, make sense?
Yeah, makes sense.
Okay, so okay, so far we are done with the math part, which bores a lot of you guys. But here, before introducing the pseudocode, I want to briefly talk about your job interviews. So, is there anyone who has been in a coding interview before? Yes or no? Anyone?
No.
So can you imagine what is the format of a coding interview? Okay, so when I was like in your situation, like when I was a sophomore or a say the second year college student, I was like, yes, the future job interview should be some high level talks. Okay, what kind of courses have you taken, and what kind of programming language can you use? Something like this, big talk. Because that's the only thing that I was able to do at that time. But unfortunately, the coding interviews are something like this. Okay, so usually you are giving around 45 minutes. So, oh, sorry, the coding interview usually is around each round of the coding interview is like 1 hour or 60 minutes or 55 minutes. Usually it's like 60 minutes. In the first 15 minutes, in the first 15 minutes, your interviewer is going to explain the question for you, the programming question for you, like what I explained for you, the route cut, the longest common subsequence problem. The interviewer is going to make sure that you understand what is the problem. And then so then in the next 45 minutes, it is your time to implement a solution to that problem, to that programming problem. But the difficulty is that, okay, there is no IDE. You are not going to be allowed to use Eclipse, because Eclipse gives you a hint. Okay, what kind of functions can you use? Also, Eclipse shows you a grammar error if you write a wrong word, keyword. So if, for example, if you do not write string, if you write sting instead of string, then Eclipse show you, okay, you have a grammar error in your code immediately. So no IDE, no internet, meaning that you cannot even go to the Java API to check what kind of functions are provided by Java already. So it's like you have so basically you are either going to write on a whiteboard if you are doing on-site job interview, whiteboard, or you are going to write on your code on a Google Doc if you are doing your job interview remotely, coding interview remotely. Okay, in 45 minutes you are going to solve the problem, to write down your code and check if your code is correct or not, and then your interviewer is going to give you a grade based on that. Is that horrible?
I think it's doable.
It's doable.
I feel
Okay.
like a whiteboard will give you a better chance to talk than to explain what you're writing, and then if you were actually doing in the IDE.
Okay, but I mean, for me, when I was in your say phase, for me this thing is really horrible, because I'm like, it's pretty like I'm going to be naked in front of someone. Yes, because you are writing the code. You're writing the code in front of someone. Okay, so when you're doing your programming homeworks, you sit in a room with yourself, and you can do a lot of whenever you make mistakes or whenever you are not sure about something, you can easily use the internet to get the answer. But in a job interview, no, all of your confusions, all of your stupidity about programming is going to be displayed to the interviewer. So that sounds pretty horrible.
Would we have to explain the complexity as well?
Yes.
Oh.
So usually this interviewer question comes with the complexity requirement. You have to design a solution within a certain amount of complexity. Okay, so you have to be extremely sharp with the complexity thing.
Yeah, that makes it hard.
Yes, and what makes it more difficult is that during the 45 minutes of when you are writing the code, your interviewer is going to keep talking with you and disturbing you. They don't do this so intentionally to lower your grade. They do it just to make sure that you understand the question and you are on track. Okay, but for me, it's really disturbing, because first I remember that in the first couple of my coding interviews, I was really nervous. And then also you have someone keep talking with you. It's really distracting. So this is what is a real job interview, a coding interview. And if you are giving a problem that can be solved by dynamic programming within this 15 minutes, your job interviewer is going to help you reach a mathematical formula like this. Okay, if you cannot derive it by yourself within 15 minutes or 10 minutes, your job interviewer is going to help you to reach this stage. But after you say such a mathematical equation, you have to say dynamic programming immediately. Otherwise, you fail the interview immediately. Okay, even though the interviewer does not ask you to terminate the interview, you failed.
Is it like one question per round of the interview?
Yes. So usually if you interview a big company like Google or Facebook, so usually you are going to go through 7 rounds of this. 7 rounds of this 60 minutes interview. Okay, so your brain is going to burn. You're going to shake, and you're going to feel nervous, and you're going to sweat a lot. It's a torture to earn that amount of salary. Just to show them, okay, you are eligible to earn that amount of salary is a torture. Okay. So how do you feel now?
I'm just
Hopefully.
thinking about how you would like get the complexity requirement.
Okay, so the complexity requirement is not that difficult because you are not going to write a very complicated piece of code within 45 minutes. So, but you have to, you need to bring something in your mind. Okay, so for example, hash means O1 complexity, O1 search complexity. Binary search tree means O log n. In a good case, or it can be or OH. So insertion sort, quick sort, whatever. So you have to bring these things in your mind already. Okay. So and then when you write down, in the next month we are going to discuss some graph search problems. You have to memorize the complexity of those algorithms in your mind. Okay. So I mean, it's hard to get a programming job, or at least to a very good company. So you have to pay the efforts. So when I was a PhD student, but this is for 7 rounds. Is for full time, but usually 3 rounds for internships. So when I was doing my PhD, so in the first year, I said, okay, I want to seek for a internship, and that experience was totally a nightmare because I didn't expect something like this. I was not prepared at all, so I couldn't find anything in the first year, and then starting from the second year, every time I want. So before every summer, say the summer internships usually starts in June, okay, and so you usually need to apply in January, okay. You usually need to apply in January. So what I do is that starting from September, I brush up my first. I spend 1 month or a little bit of 1 month go over the algorithms included in this course or in this book, and then I implement them in either Java or C++ to practice my programming, and then I go to practice more advanced interview questions. For another 6 weeks. So in total, my preparation time is like 3.5 months, and then so that's so I spent a little bit over 3 months to get prepared, and then apply, and then go. So in April, I started my interviews in April. In January, apply. And then interviews in April, and then in June I started my intern. So that is how I was able to get my internship. Okay, so similar for you. Nothing is free. Say if you are only considering some very basic company like UPS, you don't have to work that hard. But if you want to go to a better company, you have to work this hard. That's why say.
What are some good resources you suggest to like study? Is LeetCode? I've been using LeetCode to practice.
Yes, LeetCode is extremely good.
All right. Okay.
So I usually first start with this book and implement it in Java or C++, and then for the advanced interview questions. So there are 2 resources. One, I usually use 2 resources. One is called it's a book called cracking
Oh yes, I have this one too.
coding interview for fun. Crack coding interview for fun. Okay, so that book is like maybe 30, 25 bucks online. You can get one hard copy of it from Amazon, or the other one is a website named LeetCode. When I was doing that, the LeetCode only includes like around 400 questions, but now I guess it's definitely
there's like
more than 1,000.
1,800. Yeah.
Definitely it's more than 1,000 now. So it's more difficult for you to go over all the questions over there. Okay. Yeah, life is hard, right? So yes, we need to work very hard. So that's why in the beginning of the semester, I said that I definitely strongly suggest everyone to obtain a hard copy of this book, because every time when you are looking for jobs, not just internships, every time you are looking for jobs, you need to brush it up. You need to go over it once. So if you buy it now and keep some notes on it, it will save your time when you are getting prepared, when you are preparing for your interviews.
Were the questions you got from like LeetCode like similar to the questions you were asked?
So I got exactly the same questions.
Alright. Yeah, that gives a little bit
But
of
it depends on your luck. It depends on your luck. If you're lucky enough, you got exactly the same questions, okay? But if you're not lucky enough, it's going to be a different story, okay? I got a lab mate. Previously, I have a lab mate who quit his PhD. And then when he applied for jobs, he only spent around 3 months or less than 3 months preparing for jobs. So finally he landed at Google. So that guy was really lucky. So before Google interviewed him, he only had like 7 days to prepare. So what he did is that he went to LeetCode, went over all the questions with the Google tag. And fortunately, 6 of his 7 questions are exactly the same as those shown on LeetCode. So that guy did extremely good within only 1 week of preparation time. He did extremely good in his interview. Now he was able to get a job from full-time job from Google.
That's just insane.
Yes,
That's really lucky.
Yes, he's extremely lucky. For me, my interview with Google is not good. I only got 3 questions from that. So I have a social experience with Google.
Do you practice like the easy problems, the medium problems, or like the hard problems?
Actually, you need to prepare it more than once. So initially, you can start from easy to hard, and in the second time you can shuffle it, or you can go over the questions based on topic. So for example, tree, linked list, stack, graph, or dynamic programming. Okay. Any more questions for me?
Professor. Yeah. What kind of projects do you have before the interview?
As I said here, either crack the book, crack coding interview for fun, or the website named LeetCode.
I mean, do you do like any projects, like a website or like anything?
No.
No
For
portfolio?
coding interviews, to prepare coding interviews, you don't have to do a big project.
Okay.
Would they look at a portfolio?
What do you mean portfolio?
Like of projects?
No.
Things you've done. Oh, okay.
No. If you are going to be a software engineer, people are just going to hire you for coding, okay? So you just need to do this. But if you want to do something, if you don't just want to be a software engineer, so suppose that you want to be work as a researcher or R&D. R&D meaning research and development. You need to have your project. If you only want to be a software engineer, you just need to do this.
Yeah, I'm gonna start reading the book over and over again.
Yes, that's what I did. So, like at the current stage, I mean, because I have gone over that book at least 12, 13 times, maybe even more. So now, before I teach a lecture, I don't even need to read the book. I just need to spend 10 minutes to go over the slides. I can just everything just come to my brain immediately. So yes, that's how it pays off. So any other question for me? Okay, sure. So then, so let's discuss the pseudocode called LCS length XY. So with this algorithm, we will be able to calculate the length of the longest common subsequence between two input strings, X and Y. So here we have, first we got M equal to the length of X and N equal to the length of Y. And then we create two new tables, B and C. So, and then we have two for loops. And following that, we have a nested for loop. And we have some operations over here. So next, I'm going to show, to explain the pseudocode with an example. Okay, so suppose here we got two input strings, X and Y. So here, A, B, C, D, D, E.
Professor, by table, you're referring to a hash table, right?
No.
No.
Here, table means two-dimensional array.
Okay. So basically an array inside an array. Okay.
Yes. Okay, so here, suppose that we have two inputs, X and Y, two input strings, X and Y. So let's go through the pseudocode. This is the first part of the pseudocode. First, we have M equal to X dot length. What is M? Yes, 7. Okay, I say one answer in the chat area because X includes 7 characters. What about N? What is the length of Y?
6.
Yes, 6, correct. Okay, so we have m equal to 7 and n equal to 6. Okay, so next we create a new array B. So a new table or 2D array B. So whose row index starts from 1 to m, whose column index starts from 1 to n. So what is the size of B? What is the size of B?
Is it the total?
No, I mean, how many rows and how many columns? It is 7 by 6. So it has 7 rows and 6 columns. So let's write down B over here. Okay, so we first create a new array, a 2D array B, whose size is 7 by 6. And then we need to create another array, 2D array C, whose row index starts from 0 until m, whose column index starts from 0 until n. So what is the size of C? How many rows and columns does C have?
Six and seven.
6 by 7?
Six by
No.
seven.
What?
6 by 7.
No. No. So m is here. Remember that m is 7 and n is 6. So how many rows and how many columns are there?
We just multiply them. So 42.
No. You don't have to tell me.
Isn't it just 8 by 7?
Yes, it's 8 by 7 because the index starts from 0 to 7.
Okay.
So in total, there are 8 rows and 7 columns. Okay, this is an array C with this. The index starts from 0 in the array C. And the index starts from 0. Okay, so this is the 2 arrays that we created. And next we have for I starting from 0 to m. So remember m is 7. So we have C0, I0 equal to 0. Okay, so initially this is C0, 0 equal to 0, correct?
Yes.
Okay, so where is C0, 0?
It's the top left.
Yes, top left, the zeros column and the zeros row and zeros column. So we fill in a 0 over here, and and next we in the next iteration we increase I by 1. So this becomes C10 equal to 0. Where is C10? Where is C1, 0?
Row.
To the right or to the below it or on the right of it?
It'll be below, right?
Yes, it's below. 1 is the row index and 0 is the column index, so it is below. Make sense?
Yes.
Okay. And next, it becomes C2, 0 equal to 0. So basically, you can say that we keep filling zeros over here until I equal to 7. So here you can say that what we do is that we fill in zeros in the first column of C. Correct?
Yes.
Yes.
Okay. And then next we have this. We have for j starting from 1 to n is 6. So initially we have this C0, 1 is 0. Where is C0, 1?
It's row 0 and column 1.
Yes, over here, correct?
Yes.
Okay, so we put 0 over here. And then next, in the next iteration, we're going to increase j to 2. So it becomes C02 equal to 0. So C02 equal to 0. And then we keep doing that until j reaches 6 over here. So and we basically fill in zeros in these places. Correct?
Yes.
Yes.
Why do we do that? We fill in zeros in the first column and first row of C. Okay, so if we come back to the math formula here, okay, if I is 0 or j is 0, we have Cij as 0. Can we see this? C0j is 0, and Ci0 equal to 0, no matter what kind of I and j value is. Because as long as one of these cells is 0, we will assign it with a 0, correct?
Yes.
Yeah.
Okay, so that's why we put 0 in the 0th column and 0 in the 0th row. If any of the if either the row index or the column index is 0, we have Cij as 0. Correct?
Yeah, that makes sense.
Okay, so this is exactly the same. So with these two for loops, we're basically following the first case of the math formula. Make sense?
Yes.
Yes.
Any question now? Okay, so if no question, then I'm going to continue to the second part of the circle. So this is the second part of the pseudocode. So you can see that we have a nested for loop. We have I and j. So basically, we are going to use I as the row index and use j as the column index. Okay. So before continue, I also want to write down the characters. So basically, each row in the array C and array B, each row corresponds to one character from X. So I'm going to write it down. So A, B, C, B, D, A, B. Similarly, A, B, C, B, D, A, B. And each column corresponds to one character from Y. X over here and Y over here. C, A, B, A. This is X. This is Y. B, D, C, A, B, A. Okay. So let's go now. Okay. So initially we have I equal to 1 and j equal to I as 1 and j also as 1, correct? Correct?
Yes.
So I'm going to mark I over here as 1 and j, because I is the row index, so I'm going to mark I over here as to the corresponding row, the first row, and j is going to, I'm going to write j, point j to this corresponding column. Okay, so so we are going to, if I and j are the same, then we are going to compare. So no. So with I equal to 1 and j equal to 1, we're going to compare xi and yj. So we're going to compare the first character of x and the first character of y. What is xi? What is x1? It's a, or the first character of x is a. Okay, this is a. And what is yj or y1?
It's J, right?
J is 1. So what is yj?
B.
Yes, b, the first character of y. You can just, so if I, in the future, if I'm asking xi and yj or yj, you can just go to the index of it. I is here, so xi is a. J is here, so yj is b. It's easier. Okay, so this is b. So is this true or false?
False.
False. So we'll go to else if. So okay, so tell me where is Cij? So before that, tell me where is Cij or C11? Where is Cij or C11? We have I corresponding to this row and j corresponding to this column. So where is Cij?
It would be on row 2, column 2.
Here.
Column 1, yeah. Row 1, column 1.
Yes, this is Cij, right?
Yes.
Okay. So then, so let me just be general. Okay, if I tell you this is, so if I tell you, okay, well, we're giving a big matrix. We're giving a big matrix. If I tell you this is the location ij, the ith row and jth column. This is the, if this is the ith row and jth column, this is coordinate is I and j. So please tell me, where is I minus 1j, ij minus 1, and ij? Where are these coordinates? Where is I minus 1j? if the location
Right next
I,
to IJ.
IJ is here, what?
Right next to IJ.
Right next to IJ? No.
Yeah, on the left side.
No, on top of it. This is
On top
the,
of it.
yes, this is the row. So I minus 1 is one smaller than I. So it is right above it. Correct?
Yes.
Okay. So this is, we say this is top. Okay. Corresponding location is top. It's on top of IJ. So where is IJ minus 1?
To the left.
Yes, to the left. So we give the name left. Oh, sorry. The last question is, where is I minus 1, J minus 1?
It's the top left. Or like the
Yeah, top
yeah.
left. I minus 1, J minus 1 is here. Top left. Let's do not use top. Let's use up. Okay, up. So this is going to be up left. If you go up left, we'll be able to find it. Make sense?
Yes.
Yes.
The relative location between IJ and the other parts. Okay, so here. So we're talking about Cij and Cij1, J minus 1, I minus 1, J minus 1. So I minus 1, J minus 1 is just the up left. Correct?
Yes.
Yes.
Okay, up left. Let's just write them down so that is easier when we're doing. Okay, so here we're comparing Ci minus 1 vs Ci minus 1j and Cij minus 1. So I minus 1j is up. Ij minus 1 is left. So we are comparing the value up in the up with the value to its left. Correct?
Yes.
Okay. So then this is, so now we're just replacing all the I minus 1j with up. And all the ij minus 1 with left. So this is left, okay? And okay, so okay, now we finished denoting that. Okay, so previously we said that we are at this line where we are, so now we need to come, so this is ij, here is ij. So we are going to compare the value upper on the so upper ij with, well, to value on top of it to the value to the left of it. So basically we're comparing this one vs this one, correct?
Yes.
Okay, we're comparing, this is I minus 1j, say I minus 1j, this is say I j minus 1. So we're comparing their values. So they match. So this is both of them are 0. So this is true or false?
It's true.
Yes, it's true. So then we execute the next line, we'll copy the value on top of it to ij. So we copy the value from here to here, okay? And then at bij, we put an upper sign. And this denotes that this value, Cij, comes from the value on top of it. Make sense?
Yes.
Yeah, that makes sense.
Okay. Okay. So then next, okay, let's go back to the inner for loop, and then we increase j by 1, so j becomes 2. J becomes 2. So we have j over here. So this is so we're now this is the style that we're going to work on. Okay, So what we do is that, okay, next, let's first check if xi equal to yj. Here we have xi as a. What is yj? What is yj? Here, it's d. Okay, so yj is d. So is it a match?
No.
No. So we go to else if. We're going to compare the value to the upper value to the left value. So we are going to compare this value, this 0, with the value to its left. Again, they are the same, so it's true. We're going to copy the value from up to Cij, and then at Bij, we're going to put an upper sign. Any question? Are you with me?
Yes. For
Yes.
that up arrow for B, isn't that just 0?
Sorry?
For like that the up arrow for like B, isn't that just 0?
Bij is upper, the upper side.
I see.
Okay, so
Doesn't
Okay.
that correct? Oh, okay. I see.
it's just special character. Okay, so any other question? No? Okay, so next we're going to increase j by 1. So here we have xi as a and yj as c is not a match. So we're going to else if, correct?
Yes.
Yes.
We're going to compare the value to the up of it and to the against the value to the left of it. Again, they're the same, so it's true. We're going to copy the value from up to here, and then we're going to put an upper sign over here. Next, we increase j by 1. So finally, we get a match. So because we have xi as a and yj as a, so it's a match. So if it's a match, we have Cij equal to Ci minus 1, j minus 1 plus 1. So basically, we're going to get the value to its upper left, from its up left, add a 1 to it. So it is going to be 0 plus 1. So we get this value, add a 1 to it, and put it over here. Correct?
Yes.
Okay, and then at B, we're going to put the upper left side, meaning that we got the value from up left. Okay, so let's say this, okay, if xi equal to yj, we have Cij equal to Ci minus 1, j minus 1 plus 1. Exactly the same as this. If xi equal to yj, then Cij is Ci minus 1, j minus 1 plus 1. Correct?
Yes.
Okay, so this statement basically is just translates the second case of the formula to Java to programming program to pseudocode. Okay, cool. So next we increase j by 1, so j becomes here, and is it a match?
No.
No.
No, it's not a match. So we're going to compare up and left. So here we have up as 0, left as 1. So this is going to be up is 0 and left is 1. So is this true or false?
False.
False. We're going to execute the last part, the else. Okay, we're going to copy left to this cell. So left is 1. So we're going to copy 1 over here. And then put a left side in B. Correct? Correct?
Yes.
Yes.
Okay. So let's say, okay, let's look at the else if and else. Okay. If up is larger than or equal to left, we assign up to Cij. Otherwise, we assign left to Cij. So does it mean that we only assign, does it mean that Cij equal to the max between up and left? When up is left, we assign up. When it's else, it means that left is larger. When up is larger, we assign up. When in the else case, then left is larger, so we assign left. So does it mean that we have Cij equal to the max between up and left? Yes or no? Okay, when up is larger than or equal to left, we assign up. When otherwise, we assign left. Can we say that Cij is always the max between up and left?
Yes.
Yes. Okay, let me explain it in this way, okay? So if I'm saying, okay, if x is larger than or equal to y, then z equal to x, else z equal to y, okay? So does this mean that z is the max between x and y?
Yes.
Yes. So here we are basically, you only need to replace up with x, left with y, and z with Cij. So Cij is always going to be the max between up and the left, correct?
Yes.
Okay.
Yeah.
So remember, up is I minus 1 j, and left is ij minus 1. So just look here. Okay. Cij is the max between left and up, right?
Yes.
So if if the last two characters do not match, we take the max between left and up. So the basically here, the else if and else just translates the last case of the math formula into pseudocode. Correct?
Yes.
Yeah.
Okay.
Makes sense.
Cool. So type in 1 if you understand this.
Now I do.
Okay, I just want to see your match. Great. Great. Okay. Great. And the next. Okay, so we just finished the iteration at when j is 5. Next, we increase j by 1, so j goes here. And then, is it a match or not?
Yes.
Yes, it's a match, both. And so it's A and A. So we're going to take the value from up left and add 1 to it. So we're going to take this value over here and add 1 to it. So it becomes 1, and over here we put an upper left side. Okay, so then now j reaches its maximum value. So we're going to go back to the outer loop and increase I by 1. So now I becomes 2. And we restart j from 1. So here, match or not?
Yes.
Yes.
Yeah.
So we take the value from upper left, add 1 to it, upper left. And so starting from now, I'm not going to write the location of j. So now we increase j we increase j to here, match or not?
No.
No.
No, D and B not match. So we basically compare up and left. So we take whichever is larger to, we copy whichever is larger to this cell, correct? So here, left is larger. So we are going to copy left over here. And okay, next we move to this cell, match or not?
Not.
No. So we're going to compare top and the left and take whichever larger is to it. Okay, so again, it's a left. So match or not?
No.
No. So then we're going to compare up and the left. So you can see here. You can see here. Okay, when it is a match. When it is a match, so when up and the left are the same, we take up. Correct?
Yes.
Yes.
So here we take the value from up. And next, match or not?
Yes.
Yes. So we take value from top left and add 1 to it. Match or not?
No.
No, we take the value from left. So because left is larger. Okay. So next we move to this side. And so match or not?
No.
No. We compare top and the left. Top is larger. What about here?
No.
No.
No. So we take top because top is larger.
Yeah.
What about here?
Yes.
Yeah.
Yes, it's a match. We take value from top left.
No.
Okay, over here. What is this?
No.
No. So we take left.
Mhm.
What about this?
No.
No.
No, we take up.
Oh.
It's a match. They are the same. What about here?
No.
No,
We
we
take up.
up. Okay, over here, match or not?
Yeah.
Yes.
Yes.
Top.
Here, top. Yes, we take value from top because it's not a match. Over here,
No.
No.
top. Over here,
No.
top. Over here,
Yes.
upper left. What about here?
No.
Left. Here,
No.
up. What about here?
Yes.
Yes. Upper left. What about here?
No.
No. Up. What about here?
No. So
No. Up. Here? No. Up.
up.
Here? No. Up. Here?
No.
No.
No. Up. Here?
No.
No.
No. Up. Here?
No.
No. Up. Here?
Yes. Up.
Yes. Top left. Here?
No.
No. Top. Here? What about here?
Yes.
Yeah.
Yes. Top left. What about here?
Yeah.
Yes.
What about here?
No.
Up. This one is up. Here is going to be up. Here is going to be a match, correct?
Yes.
Top left. And here is going to be top because it's not a match. Okay. So then we finish filling the values in C and B. Okay. So remember, because remember that our interest is to find the length of the LCS between X and Y. And previously we say, okay, the length of that is basically CMN. So in our example, CMN is, because we have M as 7 and CN as 6. So CMN is C76. Where is C76? Where is C76?
Is it top?
Uh-huh.
It's at the bottom, so 4 and up.
Bottom right. It's the bottom right, 7, 6. It has to be this cell, bottom right cell. So it's 4. It tells us, okay, the longest common subsequence between these two strings is the length of that is 4. Okay. So next, some of you may wonder, okay, what about the say for example, what is the longest common subsequence? So then you need to come to the B. So from the bottom right, we follow the arrows to go. Okay, this is how we go from the bottom right, follow the arrows to go from the bottom right to the upper left, to the up left. And this is the route. On this route, let's say how many up left do we make? 1 up left, 2 up left, another up left, another up left. So in total, there are 4 up left, correct?
Yes.
So each of the up left corresponds to 1 character in the longest common subsequence. You can take the longest common subsequence either from Y or from X. Just go to the corresponding row, so row or column. B, C, B, A, B, C, B, A. Okay, so the longest common subsequence is B, C, B, A, which shows in B, C, B, A, B, C, B, A. Make sense?
Yeah,
Yes.
makes sense.
Yeah.
So is it cool?
That's really interesting, actually.
When I was in my undergraduate years, I didn't understand this algorithm at all. I was like, what the hell it is? So, but in my graduate years, I spent quite a long time just sitting in my office and go over the book again and again. Finally, I was able to understand it. At the time when I understand it, I was like, oh, it's so beautiful. Okay, so any question for me regarding this algorithm?
Is this do we mostly use this algorithm like very oftenly, or is it like special instances only?
What do you mean? Which algorithm? The LCS or dynamic programming?
Dimension.
Dynamic programming?
Yeah, the one which you just went over.
Okay. You mean this one, the
Yeah.
LCS one? Over
Yeah,
here?
LCS.
We only use it to solve the LCS problem, the longest common subsequence problem.
Okay.
Okay, it can only help us to solve this question. Okay. So, any other question for me? No? Do you really understand it? So just again, type in one if you think that you understand it very well. I don't see anything. Oh, I see one, single one. Only one student. A half. Okay.
Professor, I have a question.
Sure.
So would we be like, so could we use this like to find the optimal shortest path to like certain distances?
No, that's totally different algorithm.
Oh, okay.
We're going to learn it in 3 weeks.
3 weeks? Okay.
Yes. Okay. So yes, this is really hard, right? So if you don't understand it very well, please take your time to read the sub-chapter and also go over the video lecture again. I'm going to upload it tonight. It's really important, very important. So okay, and the last thing that I want to discuss with regard to this algorithm is the complexity. Okay, so previously we said that when we analyze the complexity, we only need to pay attention to 2 parts: loops and the function call. So here in this algorithm, we don't call any other function. So we only need to pay attention to for loops. So here in the first for loop, how many iterations? In the first for loop, how many iterations?
Isn't it just M?
M, yes. In the second one, how many iterations?
Well, so it's OMN and then, right?
N plus 1, because we increase j's from 0 to n. Okay, so let's just kind of like be slow. Okay, so here, in the third for loop, how many iterations?
M.
Say it.
M.
N, yes. M, it's not n, it's M. So here we got M iterations. And in the last for loop, how many iterations? How
N.
many?
N.
N, yes. So because these 2 for loops are nested, so we need to multiply the number of iterations in them. And so for the other 2 for loops, they're just parallel, so we need to sum them up. Okay, so the total complexity is OM plus N plus 1 plus M times N. So then the dominant part is M times N. So we only keep the dominant part. So the complexity of this algorithm is OMN. Make sense?
Yes.
Yeah, that makes sense.
Okay, cool. So then this is the LCS problem, and here is this is the function for us to print out the actual LCS. You don't have to implement that in your homework. So one thing when you are doing your homework is that, okay, some of you may wonder, okay, what about this? How do you handle the upper left, upper and left? So the thing is that you only need to replace each of them with a special value. Let's say you use 1 to replace up, upper left, 2 to replace up, 3 to replace left. Okay, so you don't have to use this special character. You can just use a specific value to replace that. Okay, so any question for me? Okay, so if no question, then after this lecture, you will have your homework 7, and also please read chapter 15.4. It's really important. So 15.1, 15.2, 15.1 and 15.4 are the only 2 chapters that I require everybody to read. And also a good thing is that, okay, so because the dynamic programming topic is really hard, it's very hard, and it will take some time to digest. And plus, we have more than sufficient time to finish our semester on time. So next week, so which means that next week off, okay? So even though we don't have a spring break, I'm going to give you 1 week off for next week. So you can take advantage of next week to recap the dynamical programming topic. And also, if you have any, midterm or I know that some of you have multiple midterms, like a course has 3 exams in total, so you can take advantage of that of next week to get prepared for that. Okay, so I know that some of you are overloaded. I can tell you from the emails that I received from some of you. I'm overloaded too. So over the past week, you're welcome. So for the past 10 days, I think every day I only sleep for 4 hours. Yes, I'm also very, very tired. So I can also take advantage of next week to recover a little bit, to refresh a little bit. And but I guarantee you that we don't miss anything. Okay, so still I'm going to cover everything that we plan to cover. We don't miss anything. Okay, any question for me before the end of our lecture today? If not, then so have a good night. Also enjoy the rest of the week and also next week. So I will see you in 2 weeks.
Thank you, Professor. Have a
Thank
good
you
night.
so much, Professor. Have a
See
good
you in
night.
2 weeks.
Thank you, Professor. Have a good weekend. Bye-bye.